Right, and here we have the last of these three questions. We're going to plot and label the graph of y equals 2x minus 3. We're going to solve using the graph and also using our algebra skills, what the value of y is when x equals 5, and we're going to find the gradient. So that's what we'll do. Plot and label the graph y equals 2x minus 3. To do that, we take three really simple values of x and work out what y would equal for those simple values. Three typical simple values would be x is 0, x is 1, and x is 2. So we put the value into the equation y equals 2x minus 3. When x is 0, then y would be 2 times 0, put 0 in here to x, minus 3. 2 times 0 is 0, 0 minus 3 equals minus 3. When x equals 1, we put the value of 1 into this equation, so we have 2 times x, but now x equals 1, minus 3. 2 times 1 is 2, 2 minus 3 is minus 1. 2 minus 3 is minus 1. And then when x equals 2, 2 times x, which is now 2, minus 3. 4 minus 3 is plus 1. So we now have the three simple values. When x equals 0, y equals minus 3. So we need to go minus 3 in the negative direction for y. And we just have enough space for that. So we have minus 1, minus 2, minus 3. So when x equals 1, y equals minus 3, we're at the bottom of our graph. When x equals 0, y equals minus 3. When x equals 1, y equals minus 1. That would be this coordinate here, the coordinate 1 minus 1. And when x equals 2, y equals 1. So we now have 3 points on our graph that will allow us to plot the graph. And we can continue it here. And it's much easier for you with your lined paper in your books. And we can see that this point here, let's hope that it's reasonable, minus 1 and 1. It's reasonable. So now, plot and label the graph. We've plotted y-axis, x-axis. We can put the equation of the line on the graph here, y equals 2x minus 3. And then it says, solve graphically the value of y when x equals 5. Well, to solve that graphically, we draw a perpendicular line to the x-axis and draw upwards until we actually meet the line. At the point that we cross the line, we draw another perpendicular line from the y-axis, and then we can read off the graph. And it's nice if you do dotted lines here. We can read that the value of y when x equals 5, just reading the straight off the graph, is 7. So graphically, y equals 7 when x equals 5. What about algebraically then? Well, we know that we have the formula 2x minus 3, and we need to know algebraically what does y equal. Well, y equals 2x minus 3, and x equals 5. Y equals 2 times 5 minus 3. 2 times 5 is 10. 10 minus 3 is 7. So algebraically and graphically we get identical answers. That the answer of y when x equals 5 is 7. And then the last one that it wanted you to work out here was the gradient. And the gradient you can choose anywhere on the graph that's nice and easy points. For example, it would be quite sensible here to take a line across here, because 7 minus 1 is 6. So the difference in the y-axis would be, the coordinate here is 5, 7. And the coordinate at this point here is 2, 1. So the difference in the y-axis is 7 minus 1. So here we have 7 minus 1. The difference in the y-axis is 6. The difference in the x-axis is from 5 to 2. So 5 minus 2, the difference is 3. So the gradient of this line will be the gradient is defined as equaling rise over run, which is the difference in the y-axis, 7 minus 1, divided by the difference in the x-axis, 5 minus 2, which is 6 divided by 3, which is 2. So the gradient will be defined as the rise over the run, y2 minus y1, divided by x2 minus x1, which in this case is 6 over 3, which is 2. And it wouldn't matter where on the graph you decided to measure the gradient. You could have measured it for 1 point. It's usually quite a good idea to make the gradient large and easy points to read directly off the graph. So these would have been easy points, 6 in the y-axis and 3 in the x-axis. And divide those two numbers to get the gradient.